All right, people. Let's get some test prep done. The weather's still kicking my butt. All right, as soon as I get in, it's time for the check-in. Who's in the room? All right. Okay, and as usual, I will be checking the email for test questions, so unload them. Okay, we got Jersey in the house. We got Florida in the house. All you take a picture with your smartphone. Okay. And you can send all your questions to KenoThomas at gmail.com. I'm Keno. STEM.Keno.com. Okay, we got question number 1. Gear A is traveling at 10 revolutions per minute. How many times will gear C rotate? All right. And I'm not crazy. I have a second screen. All right, let's count the number of teeth in the gear. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. All right. So gear A has 20 teeth. You have a central gear, and then you have another gear here. 1, 2, 3, 4, 5, 6, 7. And then C looks like it's the same size. 1, 2, 3, 4, 5. Hold on. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 19, 20. Now, I believe this is a typo. The reason why I believe this is a typo because our answers are 1.7, 3, and then we have 30 times. But I'll look at this. You can't really 10 revolutions per minute. So this rotates at 10 RPMs. If this is a central gear, it's going to rotate this gear, that's 7, which is connected to both of them. This should run at 10 RPMs as well. All right. So 10 revolutions per minute means that, oh, maybe it's not a typo. 10 revolutions per minute means that in 1 minute it's going to revolve 10 times. So in 3 minutes it's going to revolve 30 times. Answer Charlie. All right. So when we look at these gears, we have 20 here, we have a central gear, we have a gear here. Since this is the connecting gear, even if this is like the driver gear, if it's an equal number of gears on the other side, then it's going to rotate the same amount of RPMs, which RPM stands for revolutions per minute, and 10 revolutions per minute in 3 minutes is 30. Answer C. Type clear if you guys understood how I explained that. And message, please hit the like or dislike button. We got 3 clears in the room, and so we will press on here. All right, Thomas, you would never, ever, you'll never see a question like this on the ASTB, AFOQT, or the SIFT. It is a probability question, but this is like a crazy one. And you have to be careful because a lot of these guys, they publish books and they make them super, super hard to make you feel like, oh, this is the book. I've solved that question before on a previous video. So it's on a live stream. I'm pretty sure it might have been on a practice thing. Test that the recruiter gave you. And which test are you preparing for, sir? Because in my 10 years, no one's ever come back ASTV yet. I've never, ever had, out of 10 years of doing this, I've never had a guy come back and say they saw a question remotely looking anything like that. But I did do it in the previous live stream. If you send me, actually, I have your email. I'll just send you the link to that particular live stream and you can review it. All right. Looks like the Animation Factory. Okay, Kara. Okay. All right, Thomas. And guys, make sure you check in. Avery, how you doing, hon? Long time no see. Hope you're studying. One thing I did want to talk about, since I'm waiting on questions, one thing I did want to talk about is the you're going to have a really, really good working knowledge of understanding different forms of, or how should I say, like conversions. All right. You should have for instance, all right, 1 foot equals 0.30 meters. One inch equals 2.54 centimeters. £1 equals 0.45 kilograms. I'm going to test that or check that real quick because I don't want to give you guys bad information. But sometimes they will give you information in the they'll give you information in U.S. customary units, but the answers will be all in metric units. Yeah, I was right. Okay, £1, 1.45. I just wanted to double check that. Feet to meters, inches to centimeters, pounds to kilograms. Now, let me go to the question. I was working with someone today, and it was in the area of mechanical comprehension. And basically, not you. There we go. Let me get this to a bigger screen. Okay, be patient with me, guys. And I apologize. I'm not going to waste any more time. I will actually put it on the wall. Are you it? Think I found it. I've had a long day today. Keep feeding those questions because there's always a little bit of a delay. No, that wasn't it. Damn it. All right. All right, Avery. Okay. If 5 cans of food are needed for 7 adults for 2 days, the number of cans needed for 4 adults for 7 days is 15, 20, 25, 30, 35. All right, so what we have to do is, when we look at that, it's a word problem line by line. 5 cans are needed. So we need 5 cans of food for 7 adults. And for 2 days. And they want to know how many cans of food are needed for 4 adults for 7 days. So if this is what we're working with, we have to look at the consumption per adult. All right, per day. That's the best way. So 7 people are going to consume 5 cans for 2 days. All right, so 5 cans are going to be divided among 7 people in a 2-day period. All right, so 7 5.0 0.7. All right, 5 cans of 5 divided into 7. That's for 2 days. Then what we'll do is, that's 2 days. 0.35 will be, all right, 7 adults, 5 cans. 7 adults will consume 0.7. We get 49. It's like 0.71, but we'll just say 0.7. The 1 day will be 0.35. Wow, this is stomping me. I've solved this before. And feel free to help me out, room. 5 cans of food needed for 7 adults for 2 days. All right, how did I do this before? Oh, 15 cans. My bad. 15 cans. So this is what I did. I made a ratio. 7 adults went through 15 cans, right? So in 1 day, they would go through, these 7 people will go through 7.5, sorry. Half of 15. 7.5. All right. And then, if we take that people, cans. So 7 people consume 7.5 in 2 days. And it should be about 1 and some change of can consumption for adult. So let's just say 1.5. 4 days. 1 day. 1 person is going to eat 1.5 in 4 days. 6. And that's per 1 adult. So then, it feels like my flow is off, man. This cold's kicking my butt. Wow. I'm stumped, actually. It's 15 cans, yeah. Can you move a bit to the right? The reflection of the computer makes it hard to see. No problem, Gyro. I hope I pronounced your name right. Damn it. One person. 1.5. 7, 3. All right. I will get back to you on this one. Who gave me this? Avery. The next time we talk, we'll look into that one. Okay, you also sent, we also have another one. All right, we will go over this later. I'll probably do it like either on the Google Hangout or the live stream. I solved it before, and all right, so move right along. I will do research on that one. Okay, 2 children weighing 60 pounds and 80 pounds respectively balance a seesaw. So we have a seesaw and we have a fulcrum. Let's get another color. All right, so we have a seesaw and then we have a balance point, which is the fulcrum. We have a 60 and we have an 80 pound kid. So we have the 80 pound kid here, the 60 pound kid here. They balance the seesaw. How many feet from the fulcrum must the heavier child sit if the lighter child, this guy, is 8 feet from the fulcrum? Now, the fulcrum is just like the little teeter-totter point, or the tipping point in the middle of the seesaw. What we have to do is we have to come up with a load moment. Now, I can already see that it's 6 feet, which is Bravo. Our answers are A, 4.5 feet, Bravo, 6 feet, Charlie, 7.5 feet, Delta, 9 feet, and Echo, 10.5 feet. But I can see that it is 6 feet. With the Class 1 lever system, I always think of the fulcrum as an equal sign. And the load moment on this side has to equal the load moment on this side in order for it to balance. Now, what is load moment? Load moment is a combination of a weight and distance. We multiply the weight times the distance, and we're going to have 480 foot-pounds. That is the load moment. So on this side, we're going to have 480 foot-pounds for this to balance. And I already see that it is 6. Because if 60 times 8 is 480 foot-pounds, then 80 times 6 feet is going to be 480 foot-pounds. Answer Bravo. Now, I saw it and I had it solved. But this is what you have to look at. Your fulcrum is your equal sign. This is a Class 1 lever system. And we have 60 pounds set at 8 feet, producing 480 pounds. And the question is asking, how far is this 80-pound child going to have to be in order for this system to balance out? So it's going to be 80 times 6. Or what you could have done is You could have taken the 60 times 80 and just divided by 480 by 80, and that would give you the 6 as well. If you can't really visualize lever systems. And type in clear. All right. And how we doing on the visibility? Someone complained about the visibility. I think one of the monitors is I see it kind of showing up here on the screen. All right, keep them coming, guys. Yeah, man, it's pretty cold today in Jersey. This hot, cold weather. It's been getting me. Okay, until we get a question. Okay. Hey, Maria, how you doing? Okay. All right, so a couple announcements. I found more office space for damn near half the price. And so, like this week, I will be transferring to another office. It should really not affect the live stream. I'm not crazy. I'm looking at my screen, checking the emails and stuff like that. But it really should not affect much. But I should be fully moved in like a week. Yeah, I had to jump all over it because, like, yeah. So that's actually I hate moving, but hey, what are you gonna do? More room, almost half the price. It's kind of like a no-brainer. Because we're gonna be expanding. We're gonna be doing some more things. One of my goals was for our aviation people that come here. Just doing some live in-flight videos, like really flying a plane. Fractions, division, and multiplication. I sure can. When it comes to fractions, I have a pretty quick system for rapidly solving. I will go over division and multiplication, but I'll go over addition and subtraction as well. So my little thing is, let's say if I had 3/4 plus 1/8. What I am going to do is I'm just basically going to cross multiply the numerators and the denominators. I'm going to bring my plus sign up to remind me what I have to do. So 4 times 1 is 4. 8 times 3 is 24. And directly across. All right, so 24 plus 4 is 28, and 4 times 8 is 32, and then we just reduce. We get 14 over 16. We get 7/8, final answer. All right, so you must reduce it to its lowest terms. Same thing applies to, this only applies to addition and subtraction. So let's say we're subtracting. We're still going to use the same process. 4 times 1 is 4, but we're subtracting now. So I put my minus symbol up there to remind me what I have to do. 24 times 4 is 20, and we're still going to get to 32. Reducing to 10 over 16. Final answer, 5/8. Okay, so that's a relatively quick process. I'm not looking for the lowest common denominator and all that and everything, because the whole thing here with the test prep is to solve problems as rapidly as possible. So I want to get in there, get the answer, get out. Now, multiplication is fairly easy. Basically, if I'm multiplying fractions, say 3/8, let's just keep using 3/8, 3/4, and 1/8. What I'm going to do in this case is I'm going to multiply directly across. So 3 times 1, 4 times 8. My answers will be 3 over 32. So multiplication, we just multiply directly across. Division is different, though. Something happens with division. Division winds up becoming a multiplication problem. Why? Because we must multiply by the reciprocal 8 over 1. And what I mean by reciprocal, the numerator and the denominator, they just switch places. So we have 24 over 4, and that will equal 6. Why will that equal 6? Because I always look at it after I solve it to test it. I'll say, is 4 times 6 equal to 24? If so, then I have the right answer. Do you ever use the bow tie method when comparing? No, I never do. Maybe that cross multiplication and that I do, and maybe that might be called the bow tie method. I don't know if that's properly what they call it. It's just what I do. Something I learned a long time ago, and it's just what I do. So there we have it. Okay, it is called the bow tie method. All right, thank you. Thank you very much. So, Carolyn, to answer your question, yes, I guess I do use the bow tie method. It's like, do you bow tie your fractions? Yes, I bow tie my fractions too. All right, let's see here. One thing that people do run into problems with is when they are using mixed numbers. I'll talk about that because we had an issue that we had to clear up today with someone. If I, for instance, am, let's get a weird one, 2 3/8 times 2 1/2. All right, so there's a -2 and there's a positive. All right, what I would do is just change these into improper fractions. So 8 times 2 is 16 plus 3 is 19. -19 over 8 times 2 is 4 plus 1, 5 over 2. Then what I'm going to do at this point is multiply directly across. Now, if we're multiplying a negative number times a positive number, then our answer is going to result in a negative number. Keep that in mind. Always keep track of your signage. So 19 times 5, actually 20 times 5 is 100, so 95. All right, so -95, and then we have 16. Now, what we need to do is we got to see how many times can 16 go into 95, because if we get it like this, 9 times out of 10, the final answer will not look like this. It'll probably be in the form of a mixed number. So if it is in the form of a mixed number, we have to make sure that like if you arrived at this answer and all you saw was mixed numbers, that would tell you, oh, I got to turn this into a mixed number. So 16, this is like almost 100, right? So I would test 5, see where 5 goes. 16 times 5, 30, 80. If we add another 16, that will put us at 96. It's too big. So I'll take 80. And remember, this is a negative number. So 5, 16 will remain in the bottom. 5 times 16 is 80. And then what gets us to 95? Another 15. So it's negative 5 and 15 sixteenths. So whenever I get questions like this, I'm automatically changing them to improper fractions and then multiplying directly across. It's more efficient, and it just helps you solve quicker. I guess what I could do. Okay, here we go. There we go. I found it. All right, here's the question. What is the potential energy of a 4-pound book held 50 feet in the air? Anybody that's done mechanical comprehension with me, they know energy is the sum of kinetic and potential energy. And the formula for potential energy is potential energy that deals with height. Okay, so we have a 4-pound book, and it is 50 feet in the air. And our answer comes in joules. We have 1960 joules. We have 268 joules. We have 200 joules. And then we have 27 joules. A joule is a unit of energy. And that's how we kind of measure. It's the units for energy. Like you would have units for feet, pounds, newtons, kilograms, whatever. When we compute potential energy, or kinetic energy, the answer is going to be in a number of joules. That is the unit. And it's spelled Joules, joules. Okay, so the problem is my formula for, I put E for energy, PE for potential energy, is mass times gravity times height. Mass is in kilograms. Gravity is 9.8 meters per second squared, acting on a falling object, and the height is 50 feet. So what did I say? I said 1 pound. I shouldn't put that equal sign there. Is equal to how many kilograms, guys? Who's paying attention in the room? And then we're going to have to look at meters. 1 meter is equal to, or 1 foot, sorry, is equal to how many meters, guys? Looking for answers in the room, because I did put it up on the board earlier, and you guys should be taking notes. Okay, who remembers? Maybe 20 minutes ago, I had it up on the board. Okay, good. 1 foot is 0.3 meters. What about the pounds? What about the pounds, guys? Tell me about the pounds, George. That crazy movie of Mice and Men. All right, Thomas is in the house, 0.45 kilograms. All right, so the question, let me come back to the question, because I like to look at the question, but I had to step back to see what your responses were. Okay, so, wrong window. Where you at? Okay, so what is the potential energy of of a 4-pound book held 50 feet in the air. All right, so let's explore pounds for a sec. If 1 pound is 0.45 kilograms, all right, 1 pound, 0.45 kilograms, then actually no, 50 pounds is going to be equal to 50 times 0.45 divided by, well, actually, that's what it would be, 50 times 4.5. Because we divide by 1, it's really just going to be the number. So 1 pound is 45 kilograms, and I'm really screwing this up. But I call it myself. Trolls that are out there, not you guys. All right, 1 pound is 0.45 kilograms. So 4 pounds is actually going to be this multiplied by 4. 0.45 plus 0.45 is 0.9. And so we would have 1.8 kilograms. All right. So here, 1.8 kilograms is our mass. Gravity is 9.8. Now our feet. 50 feet, 1 foot is equal to 0.3 meters. All right. So we'll do our next ratio. All right, so sometimes you are going to have to convert, and so you should have those quick little things in your head. All right, so 50 feet, or I could change it around. It doesn't matter. 1 foot, 0.3 meters. And actually, you know what? The ones are pretty good because whatever you multiply, that's pretty much what you're going to get. So 50 times 0.3. 150. 15 meters. So our height is going to be 15 meters. All right, guys, let's jump in. I want you guys to calculate 1.8 times 9.8 times 15 meters and tell me what you guys get. And again, the answers are 1960, 268, 227. So I set up the pens, you guys knock them down. All right. And it's the only thing that's left is multiplication. 1.8 times 9.8 times 15. Somebody came in with 27 joules. To 18. I don't know. Does anybody else agree with that? Don't be shy. Put those entries in, guys. Little crowd participation. Never hurt. Okay, we got 269 in the room, which would be closest to 268. All right. $1.8 times 9.8 times 15. Those are your numbers. Welcome to the room, Michael. What test are you preparing for? I wouldn't say 27. Welcome to the room, sir. We're here every week doing questions pertaining to the AFO QT. 264.6. So I would go with Bravo. You have 1960, 207 joules. All right. So Bravo's the closest. And oops, I put 1.5 instead of 15. That was my error. Yeah, you know what? There's like a little dot here. I touched the board with the tip of the marker. So that's an honest mistake. All right. Question for the room. How many classes of levers are there? That's a mechanical comprehension test. Our OAR, ASTB, and SIF guys would need to know something like that. How many classes of errors? Thomas knows. 3 classes. And anybody in the room, what is the difference between a second and a third class lever system? Any takers? On the second, the third class is on the end as well, sir. All right. We did a question earlier with the first class. A second class would look like this. A third class could look like this. All right, so the fulcrum is on the end. All right, second and third class are similar to a catapult. Yeah, that is true. The load positions change. This is the second class. This is the third class. The load acting downward will be in between the fulcrum and the effort. So we'll put L for load, E for effort, and the wheelbarrow is the best example of this. A catapult would have the load on the end and the effort here. So that is the difference. The effort and the loads, they just change position. They swap positions. All right. So that is the difference between the second and the third class lever system. All right. So I don't normally do mechanical engineering questions. I normally reserve that for mine, but I'll do like a couple here. Okay. More important. What is the first law of motion? First law of motion, guys. And I'm talking about Sir Isaac Newton's laws. And it is frequently referred to as the law of inertia. Or I think the law of mass and inertia, actually. Nobody knows? Okay. The first thing we'll talk about is inertia. The inertia is the tendency of an object to either stay still, stay at rest, or continue moving in uniform motion at a straight path. And I was working actually with Kara today, I think. It's either Kara or Tyler, I can't remember. I think it was Kara. But here's the thing. You ever see those crash test dummies? How they're like sitting in the seat? All right. And it's sitting in the car goes forward. Okay, object remains in constant motion until acted upon by outside force. Object at rest also. So in the law, it talks about being at rest and being in motion, because that's your inertia, your tendency to either stay put or keep moving in uniform motion. So the crash test dummy goes forward, right? The car hits the thing, and then what happens to the crash test dummy with no seatbelt? They're kind of thrown forward because they don't have a seatbelt. So even though the car has stopped, the inertia of the body will still want to go forward. And that's why we wear seatbelts, to keep our inertia still. So if you have seatbelts, you flex against the seatbelts, and then boom, and you should come back if your seatbelt's working properly. They also invented airbags to kind of keep you positioned still. So that's Newton's first law of motion. Newton's second law of motion is expressed in a formula: force equals mass times acceleration. Force equals mass times acceleration. And force is in newtons, mass is in kilograms, and acceleration meters per second squared. All right. What is the... If I take my pen, my dry erase marker, and I release it, okay, what is the acceleration of gravity in meters per second, which is the system, international or metric system, and the U.S. customary system, or I think they call it the English or British system. Can't remember. 9.8 meters per second squared. Okay, it's very, very important. 9.8 meters per second squared. An acceleration rate tells you that every second that is the pylon, 9.8 meters. So the first second I'm moving at 9.8 meters per second. The second I'm moving at 19.6 meters per second. And I'm not going to do 3 seconds in my head, but it's very, very important. A lot of people don't grasp that basic concept. All right. So that is acceleration. And then I will address one last, hold on. All right, hold on. My favorite. Okay, we had and then Newton's third law of motion: for every force is an equal opposite force. So Thomas will get the last question. How much pure acid must be added to 10 ounces of 50% acid solution in order to produce a 75% acid solution? Our answer is 5 ounces, 6 ounces, 7 ounces, 8 ounces. Now, I love mixture problems, don't I, Avery? The way I teach it is I teach container, like a container method. All right, so we have 2 containers with different types of solution in them. All right, and then they're going to equal a final solution. So I'll write information here. I'll now write information here. I will write the quantity, and I will write the percentage, but I will convert it to decimal form. So that's what that deci means, decimal. So as I go along, 10 ounces of 50% acid solution. So we have 10 ounces, 50% acid. 50% is 50. But in decimal form, the decimal point moves 2 places to the right, and we get 0.5. So that's the percentage. We have pure acid, so we have an unknown number of ounces that we're going to be adding, but 100% is 1.0. All right. So what we're going to produce is a 0.75% solution. So again, I'll reword the question. How much pure acid must be added to 10 ounces of 50% acid solution in order to produce a 75% solution? Now, this is very easy because what we're going to do is we're going to kind of multiply downward, come up with numbers to add, and then they're going to equal the percentage times the sum of the quantities up top. All right, so 1x, because 1 times x, the unknown amount of 100% solution is unknown. All right. Then 5 or 50% times 10, or you can say 10 times 50. It doesn't matter, but I will keep it in the format. So 0.5 times 10 ounces is equal to the percentage of the new solution times the sum of our first two containers. So we have 0.75 times 10 plus X, because 10 ounces plus the unknown is the sum of the solution. So we have 1X, and this is 1.0, all right, which is 1. And this is actually just going to turn into 0.5. And then 7.5 must be distributed into the parentheses. So up here, we're going to get multiplied by 10, decimal point moves over 1, 7.5 plus 0.75x. So all we're going to do at this point is combine like terms. How I do this is I look to see what side is x biggest on. X is biggest on this side because we have 0.75x. And I'll cross this line out because this is what we did when we distributed. We got 7.5 plus 0.75x when we did that. So our new line will be 1x plus 0.5 equals 7.5 plus 0.75x. We combine like terms. So what happens here? I'm going to send the negative, 0.75 will jump the equal sign and become negative, leaving us with 0.25x. And then the 0.5 is actually going to go to the other side and become negative. So negative 0.5 minus positive 7.5 will leave us with 7.0. And then I'm going to go to my little board here, and I'm going to subtract 20.25 from both sides, which cancels out here. 0.25 will be on the outside of the house, and 7.0 will be there, but I'll add another 0 because we have 0.25. So the decimal must be moved in twice. And if we do that here, we have to do it under the house. So the decimal comes here and in our answer. Now, how many times does 25 go into 7? 0 times. How many times does 25 go into 70? 2. 3 would be 75. So 2 would be 50. We get a 2, 0. Another 0 comes down. 25 goes into 208 times. All right, and let me just come back to the question. All right. Let me just look at this again, because my math could possibly be off. It happens, guys. Every once in a blue. All right, just checking my math. 0.25, negative goes over there. 0.75 times 10. Decimal moved over to 7.5. All right, so 7 divided by 0.25 equals 28. So that's a little bit, I don't know if you typed in the answers wrong or if that's a typo, but according to my calculations, 28 ounces of pure solution must be added here in order to mix with the 10 ounces of 50% solution to raise that liquid concentration to 75% acid solution. I got the book. I can't seem to find it. Okay. Okay, so it is 10:02. If you're interested in coming to the Google Hangout, just send me an email. Make sure you send me an email so I can reply with the link. And in closing, I'm Keno Thomas with STEMwithKeno.com. I'm here every week. The live stream is always free. The Google Hangout, however, is not. It's for my clients that have worked with me during the week. if you need one-on-one tutoring, then you can just go to stemwithkino.com. I will type it in. On the message board. All right, so that is the website if you guys need help. What else? Not only do I do military, but i.e. the title, military and FAA test prep. All the military aptitude tests and all the pilot certification tests, private pilot, instrument pilot, commercial pilot, airline transport pilot, certified flight instructor, initial certified flight instructor, instrument and multi-engine instructor. I did say ATP, and all the aviation ground instructor ratings. I've earned them all. I know the testing process. So, I mean, here's where you can bring questions. Maybe you don't understand something in your oral exam that's coming up or whatever. Practical test standards, airplane characteristics. So, you know, here is a source. I'm here for you every week. And I do provide one-on-one tutoring. So, with that, I'm going to go to my email, see who wants to come to the Google Hangout, if anybody is interested. And if not, I'm going to get some sleep. So, you know, I thank you guys. I really appreciate you guys for coming out. And I'm here every week. The best way you can get the most out of this is to bring your book, take pictures with your smartphone, and, just bring your questions to the room. I will execute them. And again, I don't know every question, but I can research questions and find the answers at a later date, put them in the next live stream. Because I've solved that one question. I've done it a bunch of times, but I don't know. I've had a long day. My head's not in the right place right now, I guess. With all the moving and everything, I'm just like a little frazzled. Because I had to move stuff, and then I got to get back. The one office, I got to keep everything set up as far as my live stream goes. And then, so I figured I'd do the live stream tonight, and then I got all week to transfer it to the new office. So I hope to see you guys at the new location, or me, I guess, broadcasting, I guess I could say, from the next location. And that's really about it, guys. So I will check my email and look for you guys. And until then, I'm Kino with STEMwithKino.com. Have a great night, and thanks for watching. I really, really appreciate it. And I'm doing my little finger button thing. Good night. Bang.